Okay, next part of the problem. I will warn you, this is a really good example of where if you start to feel like you're getting stuck, you want to move on. You should not get stuck on the AP test. You just keep moving. Don't get stuck until you've done everything you can. The function h now, defined by this formula, so definitely pay attention to that. This is the function h. Find the x-coordinate of each critical point of h. Stop right there. Once they ask you to do something, you should stop. H has a critical point when h prime is equal to 0. You can pull out those, it would be the white notes that you were given way earlier in the year when we thought you had everything memorized. You can use those notes now on the AP test. If you need another copy, send me an email or a text and I'll be glad to post that. So I'm looking for h prime is equal to 0. So I need to go find h prime. This is my formula for h. So I write h prime of x is going to equal, the derivative of g is g prime, minus 1/2 is a multiplying constant. The derivative of x squared would be 2x. You can stop there, you don't have to simplify. If you get that far, they will give you 1 point for finding h prime. But I'm supposed to figure out where h prime is equal to 0. So I'm going to do that. Put a 0 here. These divide out, so this becomes minus x. So this equation, h prime has a value of 0 whenever g prime, these two are the same, so that when they subtract you end up with 0. So I'm looking for where g prime has a value equal to x. So a little bit weird. This is where honestly I got stuck on the problem and I would have had to move on. I've earned 1 point. In past years, this particular problem is worth 4 total, but getting 1 of the 4 on this was plenty enough. So again, don't let yourself get stuck, but I'll keep explaining. So anyway, g prime equals x means somewhere on this graph, the x-coordinate and the y-coordinate are the same, because g prime of x is each and every one of these y-coordinates, because this is the graph of g prime. So over here it doesn't work. Here x is -7 and g prime is -1. They are certainly not equal. Nowhere along here will they be equal either, because this is x equal -6. This isn't g prime equal -6. X equal -5. This is not g prime equaling -5, etc. So I know none of those work. Right in here, it can't work either, because these are all negative x-coordinates and these are positive values of g prime. So you won't have a place where the y-coordinate on g prime is the same as the x. Over here there's going to be a spot. Visually it appears to be about right in here, where the y-coordinate of g prime is the same as the x. So I have to find that somehow. This is where the problem becomes extremely difficult. Well, in my opinion, it becomes very difficult. So I keep moving because I don't know how to do that. So I go to here. Here's one. The value of x is 3. The value of g prime is also 3. So g prime is equal to x at x equal 3. That's one of those places. If I got that far, so I keep going. To find this spot, turns out what you have to do, and if you honestly don't think you could ever think of doing this, don't worry about it. Again, your goal in the AP test is not to get all the problems right. Your goal is just to get as many points as you can. In past years, 55% has been a 4, 66% has been a 5. I don't know if that will be the same this year or not, but you still want to have the strategy of just get as many points as you can. Okay, I've got to find this. Well, this is on a circle. So if you happen to remember, the equation for a circle that's centered at 0 is x squared plus y squared is equal to the radius squared. The radius here is 2, 2 squared is 4. And then rearranging, we get y squared is equal to 4 subtract x squared. So y is equal to the square root of 4 minus x squared. And what we're looking for is somewhere on this curve where this coordinate is the same as x. So we want to solve a new equation here, so I'm going to copy this over. Please do not get too worried about this part of the problem. If you can solve it, great. If you can't, it's totally okay. The goal is not to get all the points. The goal is to get as many points as you can. You do not want to get stuck working on a problem where you just churn and don't make progress. But anyway, I'm solving this equation now. So I square both sides. I add x squared to both sides, so now there'll be an x squared, 2x squareds. I divide both sides by 2, and then I take the square root. So the x-coordinate, up here, root 2 is about 1.4. That x-coordinate is where the y-coordinate is the same. So I've now found the 2 points, x equal 3 and x equal root 2. Those are the 2 critical points. I'd have to write that down. So I would say h has critical points because it asked me to find the x-coordinate of each critical point of h. So h has critical points at x equal 3 and x equal root 2. That is a lot of work, and that was worth 1 point. That's why I'll say again, don't let yourself get stuck. The first point on this problem was not difficult at all. So I just keep going, and if I start to feel stuck, I just move on to something else. But here I would have gotten that point for sure. I don't think I would have remembered how to get this point. It's just, I haven't used the equation of a circle for many, many years. That's what was needed to get that second point. I want to keep talking about it though because the next concept does show up on FRQs fairly regularly, and it usually shows up in places that are easier to solve than this one. So we keep reading. We're supposed to now classify each critical point, so we're supposed to figure out x equal 3 and x equal root 2. Is that the location of a relative min, relative max, or neither one? And we have to explain our reasoning. So here's where, because I don't have any way of, so I'm trying to figure out if h has a relative min, relative max, or neither. So I remember this definition. H has a relative max when h prime changes positive to negative. So I've got to figure out how h prime changes. So I want to do a sign chart of h prime. So if I had a way of graphing h prime, I would just graph it because I can use a calculator on any problem on the test this year. But don't have a way to graph h prime. I know h prime is equal to g prime minus x. But I don't have a way to really graph h prime because I don't have a good way to graph g prime on my calculator. So a sign chart will have to do. The good news is I already know the two places on the sign chart. In fact, we should make a slightly different here. Put 0 over here. So here's root 2, and then here's 3. These are zeros. Now I just have to do some testing. So h prime. So I just pick a number bigger than 3, like 4 is fine. 1, 2, 3, 4. So g prime of 4 is going to be about here. That's about 1. But x is also 4. So you're going to end up with about 1 minus 4. That's definitely negative. So over here, this is definitely negative. Then I try this side, like plug in root 2. So 2 is a good one to check. So if I come up here, this is again another good example of how these last 3 points on this problem are difficult to get. But I go to 2, well, g prime of 2 is 0. So 0 minus 2 is going to be, 0 minus 2 is going to be negative as well. So these are all negative. If I plug in 0, g prime of 0 is 2. 2 subtract 0 would be positive. Now I can write down my answer. Finally, I say h prime changes positive to negative at x equal root 2. So x equal root 2 is a relative max on h. If I write that out, they'll give me 1 point. So reviewing again, I earned 1 point for finding the formula for h prime. I earned the second point for identifying that h has critical points at these two x coordinates. I now have earned a third point by writing this statement in red. You have to have the statement. The fourth point, the wording is going to be very similar to this red one, but we'll copy it over here. So the fourth point is I write at x equal 3, h prime doesn't change positive to negative or negative to positive. So h, not h prime, h doesn't have a relative min or relative max at x equal 3. And if I write that, x equal 3, that will give me 1 more point, which means on this particular problem labeled C, it's actually was problem 5C originally, that was 4 points.